As you can see, Theodore Myman developed the first working laser at Hughes Research Lab in 1960s, and his paper describing the operation of the first laser was published in Nature 3 months later. Myman's early laser used a powerful energy source to excite atoms in a synthetic ruby to higher energy levels. At a specific energy level, some atoms emitted particles of light called photons. These newly created photons struck over other atoms, rapidly stimulating the emission of more identical photons and amplifying the light intensity. Myman was able to continue his process of stimulated emission and amplification by placing a completely reflecting silver mirror on one end of the model and partially reflecting silver mirror on the other. This setup enabled photons to bounce back and forth between the mirrors until they gain enough intensity to burst through the partially silvered end as a powerful coherent beam of light, which is what you can today find on the end of a laser pointer. So, what is stimulated emission? Stimulated emission in laser action means the release of energy from an excited atom by artificial means. According to Albert Einstein, when more atoms occupy a higher energy state than a lower one under normal temperature equilibrium, it is possible to force atoms to return to an unexcited state by stimulating them with the same energy as would be emitted naturally. In stimulated emission, the emitted light wave will be coherent with the incoming wave. In laser action, the stimulating emission triggers a chain reaction in which the radiation from one atom stimulates another in succession until all the excited atoms in the system have returned to normalcy. By doing so, the coherent monochromatic light, which is the light of a single wavelength, is emitted.
The free electron laser FEL is an exceptional kind of laser. Its active medium is not matter, but charged particles, which is electrons accelerated to high energies, passing in vacuum through a periodic undulating magnetic field. This is in contrast to conventional atomic and molecular lasers, in which the electron performs radiative transition between bound quantum states. This phenomenon was first predicted by Albert Einstein in 1917. As part of his work on the theory of general relativity, in his paper titled The Quantum Theory der Strahlung, which means on the quantum theory of radiation, Einstein proposed that under certain conditions, an atom could be stimulated to emit light of a specific frequency, which would be in phase with the incoming light and thus creates a coherent beam. This prediction was later experimentally verified by various researchers, leading to the development of the laser technology that we use now. In this modern era, lasers are used extensively in fiber optic communication systems, usually used to transmit information over long distances. The laser beam is used to carry information by encoding it onto the light waves, which are then sent through the fiber optic cable.